This is a question that I want us to go through. S7 says it's coming from 2016. 16 moles of hydrochloric acid. 16 moles of hydrochloric acid react with 2 moles of, this is potassium dichromate. This is potassium permanganate or potassium dichromate. I confuse these two. Or maybe they are the ones that confuse me. Potassium permanganate. Yes, potassium permanganate. That's right. So hydrochloric acid reacting with potassium permanganate to form manganese chloride plus potassium chloride plus chlorine gas, as well as 8 moles of water. So the first question says, what is meant by redox reaction? What do you understand by redox reactions?
A redox reaction is a reaction that involves the transfer of electrons from one species to another by being oxidized.
You have just talked about being oxidized. What about reduction? Remember, redox is a compound term that is made up of reduction and oxidation. So what type of reaction is that there?
Okay, so the reduction and oxidation of electrons.
Don't restrict yourself to one item. Remember, reduction and oxidation can be defined not only electrons, can talk about oxygen, can talk about hydrogen, can also talk about oxidation number. So it's better just say it's a reaction where both reduction and the oxidation occurs at the same time.
Okay.
So RED comes from reduction, and then OX comes from oxidation. So it's a two-way thing that is involved within the same chemical reaction. So redox reaction, these are reactions that involve both reduction and oxidation, or you can say these are types of reactions where both oxidation and reduction take place.
Okay.
And B, are you getting the point?
Yes, I got it, sir.
Yeah, because let's say reduction, let us try to define it in terms of reduction. Let's try to define it in terms of oxygen loss. So when one chemical species loses oxygen, there must be another one to gain the oxygen. So both the two are happening at the same time. And these two reactions cannot be separated. When one is sending money, there must be someone receive it. You get a point?
Yes, sir.
Yeah. Then B says, calculate the oxidation state of chlorine in hydrochloric acid and explain why a change from HCl to Cl2. So first of all, we have to understand that in this HCl that we have got hydrogen, we also have chlorine. But the one that they've told us to determine is chlorine. And we also have to understand that there is one atom of hydrogen and one atom of chlorine. So we are going to say that the oxidation state, and the other thing that we have to pay attention to, the overall charge. In HCl, the overall charge is 0. This is a molecule or this is a compound which is not charged. So when you're determining the oxidation state, we make sure that whatever computation that we do inside must be equated to 0. So we'll say that here there is oxygen, which is just 1. So we're going to get the oxidation state of hydrogen, not oxygen. We get the oxidation state of hydrogen. We multiply by 1 because there's only 1 atom. We add 2, 1, which is chlorine. Chlorine is also just 1. So we multiply by 1, and the answer is equated to 0. And at this point, we are going to tell the only difference which is there between the oxidation state and the charge is that if the charge is 4 plus, if the charge is 4 plus, the oxidation number or the oxidation state will be written as plus 4. That's the only difference which is there. So actually, the understanding of oxidation states is got to do with the bonding. That's why yesterday I made that video so that we get to be reminded on how these charges are formed. It all comes from the electronic configuration. So hydrogen, which only has 1 electron in the outermost shell as the only electron, when you write the configuration, it's going to have 1. And this one can easily be lost, and when it loses that electron, the charge becomes 1 plus or 1 plus. Now, the oxidation state will be written as C plus 1. But this thing here, we are multiplying by 1, sorry, because there's only 1 atom of hydrogen. So this is what we are doing. So to write it in a better way, we are going to say that hydrogen, when it loses the very electron that it has, it becomes positively charged. Now, as a charge, we start with a number, but oxidation state, we are starting with a letter, with a symbol. So it is that oxidation state, we multiply by the number of atoms that they are, which is just 1. We add 2. Chlorine, we do not know, and that's what we want, but there's only 1 atom. So we just multiply by 1, and then we equate to 0. I'll repeat. Whenever an element is given, try to write the electron configuration. From the electron configuration, you are able to tell whether it is going to have a positive charge or it's going to have a negative charge. That very charge that you have, start with the charge, then the number later, it changes from a charge to an oxidation number or the oxidation state. So here, when we multiply the plus 1 times 1, we're just going to have, it's going to have a plus 1. Now this plus 1, when we multiply it, this plus 1 that we have, when we multiply it, just okay. Now this plus 1 that we have, we're saying we have plus 1 times 1, just plus 1. Then we add 2 chlorine, we equate everything to 0. Because there we are saying chlorine, 1 atom of chlorine times 1 still gives us 1 atom of chlorine. Then at this point, what we're supposed to do now is to collect the like terms. This value goes there. It is a positive, it becomes now minus. So this will give us Cl is equal to 0 minus 1 still gives us minus 1. So this is the oxidation state of chlorine in the molecule of HCl. That's how it's done. So you always have to pay attention to the charge. Just change the charge, you start with a number. 4 plus, 2 plus, 3 plus, 2 minus. But the oxidation state, you switch, you start with a charge, then you end with a number, it becomes the oxidation state. Now, the other question says, why is there a change from HCl to Cl minus? So this thing that we have here has got hydrogen and chlorine. But now in the process, hydrogen is lost. When hydrogen is lost, we are calling it oxidation. We are calling it oxidation. And when this thing, so let's say we have 16 of them, But once one of them loses hydrogen, another one loses hydrogen. So what happens is that this chlorine that is remaining, the chloride ion, the radical, as well as that chloride that remain, they are able to couple together and they form a molecule like that. So the question here will say, explain why the change from this to that. What was happening is that hydrochloric acid was reduced. So the change is a result of the reduction of hydrochloric acid. Or you can talk about in terms of loss of hydrogen. We can see it from here that this substance has got hydrogen with it, but at the end of the day here, we don't have any hydrogen that is attached to a chloride ion or the chlorine atom. So the change is because of the oxidation process. Are we together? Are you there? Okay. Then C says, calculate the oxidation state of manganese Mn in potassium permanganate. Calculate the oxidation state of manganese in potassium permanganate. So the process is just the same thing that we did. It is just the same thing that we did. We also have to assign here, 1, the number of atoms, 2, the charge that they will possess, which will be converted to oxidation state. So we have potassium right from here. Potassium is just 1, so 1 times potassium. That is added to, there's only 1 atom of manganese, so that one also multiplies 1. We add 2, there are 4 atoms of oxygen. So it's all times 4. And again there, the overall charge is 0. So we equate everything right to 0. The same thing, if you remember very well, that you can stop the video for a while and then try to be reminded. Potassium is 39 and 19. So the configuration is 2, 8, that is already 18, only 1 remains. So when this very electron is lost, the charge becomes positive. So meaning the oxidation state now for potassium here becomes, the oxidation state for potassium now here becomes +1, which when multiplied with that 1 still gives us +1. Now, because we have done much of calculations, so I don't need to waste time now. So there, manganese also, 1 atom of manganese multiplied by 1 just gives us manganese, plus there it's oxygen. Oxygen, again, let me try to explain a little bit. So we've got oxygen, we've got 16 here, and we got 8. So it's 2,6. Now these 6 that are in the outermost shell, this element needs 2 electrons. And when these two electrons are gained, the charge becomes 2 minus. But now the oxidation state is written as minus 2. So here we say minus 2. And everything here must be equated to 0 because the overall charge on the compound there is 0. We don't have any charge around here. So we equate everything to 0. And then at this point, we are going to just do away with like terms. So we have a plus 1. We've got, let me just make a correction here. It's 2 minus, remember, but now there are 4 atoms. So one atom of oxygen contributes 2 minus, but now because there are 4 of them, here we must have negative 8. Each one 2 minus, 2 minus, 2 minus, 2 minus. There are 4 of them, so we equate everything to 0. It is at this point now when we're supposed to work around the oxidation state, the like terms. And according to our grade 7 mathematics teacher, they told us that when signs are different, you subtract, get a sign from the bigger number. So when you deal with a positive 1 and minus 11, minus 8, what remains is minus 7. So minus 7, we add to manganese. We add to manganese and everything is equated to 0. At this point, we collect like terms so that manganese remains, and this is going to be, because this is negative, when it gets this side, it becomes plus 7. So the oxidation state of manganese in potassium permanganate is plus 7. As simple as that. So a reminder, when finding the oxidation state, please make sure that you write the electron configuration if you've forgotten. Write electron configuration, go and watch my previous video, and then you're going to get a hint on how the charge is ascertained, whether positive, whether negative, what is the magnitude of the charge, all that was explained in the previous video. So this is now just a summary of what was taught in there, as well as now the consolidation of the actual process. But now, again, when you go back up here, remember, even people in life, there are some people, when they are around you, you don't appreciate them. Actually, you feel better when they are not there, when they are gone. And there are some people that you wouldn't want to lose in life. So even elements, the very important element that any other element wouldn't want to lose is oxygen. So the loss of oxygen, that was also explained in the other video that was made. The loss of oxygen is called reduction. So if you look around here, potassium permanganate had oxygen with it, but this potassium which is here, there's no oxygen. This manganese which is here, there's no oxygen. Therefore, we would say that potassium permanganate, what happened? It lost oxygen. As a result, it was reduced. It was reduced, and the reaction is called reduction. But for as long as there's one who has lost oxygen, there must be another one to receive. So when potassium permanganate gets reduced, there is another guy who gets oxidized. Now, substances that get reduced, substances that get oxidized are only reactants. So because this potassium permanganate was reduced, we expect this other guy to get oxidized. But how is the oxidation being brought about? So this guy was oxidized. And this is what we are calling oxidation. How was it brought about? Hydrogen is an element that anyone wouldn't want to be around with. So the loss of hydrogen by a compound is not being reduced. Actually, it's being oxidized, which also explained in other ways. So the loss of hydrogen is oxidation. The loss of oxygen is reduction. So we can clearly see that both oxidation and reduction are happening at the same time, simultaneously. Therefore, this qualifies to be a redox reaction. So redox reaction, like I explained earlier, is a type of reactions where both reduction and oxidation happen at the same time. So what can we get from this? If we go to the last point of this slide, of this page, says, is the change from potassium permanganate to manganese chloride, is it a reduction? Is it an oxidation? Without wasting much of the time, we'll focus on oxygen. What happened to oxygen? Oxygen is gone. So because there was loss of oxygen, this reaction is called reduction. It's a reduction because there was loss of oxygen. The potassium permanganate has got oxygen with it, the molecule, but the manganese chloride, you can clearly see that there is no oxygen.